In this video, we're asked to use an explicit u-substitution to compute the integral of x squared square root of x plus 1. And this is a classic sort of integral. The substitution that we make to make progress here is to just simplify the interior of the square root to a single thing. In other words, we let u equal x plus 1. So the square root piece is going to clean up to square root of u. But then we have to deal with the x squared piece that's sitting out in front. And the way we do this is to solve for x in our original substitution. So x is u minus 1. And that means x squared is going to be the quantity u minus 1 squared. So we transform the integral, and we have the quantity u minus 1 squared times the square root of u du. And this integral is no problem. We can expand that squared binomial and then distribute the square root of u, which is the same as u to the 1/2. So I get a u squared minus 2u plus 1 times u to the 1/2. And when I distribute that u to the 1/2, I get three terms that are all powers of u, and then we just use the power rule on each of those terms. So I get a u to the 5/2. 5/2 is just 2 plus a half. And then I get a minus 2u to the 3/2, and then a plus u to the 1/2 du, and we use the power rule on each of these. So we're adding 1 to the exponent and dividing by the resulting number. In the first term, this gives me a u to the 7/2 divided by 7/2, which is the same as multiplying by 2/7. In the next term, I get a u to the 5/2 divided by 5/2, which is the same as multiplying by 2/5. And I'm going to combine that with the 2 that was already there, and I get a minus 4/5 u to the 5/2. And finally, I get a u to the 3/2 times 2/3. And we have our arbitrary constant plus c. To wrap things up, we're going to sub in our original definition of u, which is x plus 1. And we arrive at our final answer. We have 2/7 times the quantity x plus 1 to the 7/2 minus 4/5 times the quantity x plus 1 to the 5/2 plus 2/3 times the quantity x plus 1 to the 3/2 plus c. And we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.